All right, guys, welcome back to part 2 of 7.3 notes. Now, from here on out, we're using elimination. All right, and I'm not saying at this point it's more convenient than substitution and graphing. I'm just saying it's a different one, and it's always nice to have different tools in the arsenal. So here's our battle cry. We need either the x values to be twins, good twin, bad twin, or we need the y values to be twins. So when I look at this system right off the bat, I'm thinking to myself, get myself a little bit of room. Which of these variables would be easiest to get the number in front of y to be the same or the number in front of x to be the same? In which one is negative and one is positive? Well, as I look at 2x minus y equals 4, I can make y negative 3 very easily by multiplying by positive 3, because a positive 3 times negative y would be negative 3y. Okay, so if I do that to the top equation, then I don't have to do anything to the bottom equation. So you take 3 times 4, 3 times negative y, and 3 times 2x. That gives you 6x minus 3y equals 12. On top, on the bottom, again, if it's blue, that means nothing was changed. 7x plus 3y equals 27. All right, the next move is adding this column will eliminate the variable. So if I add here, then I have to add here and I have to add there. Just make sure it's consistent, right? So adding the column eliminates the y value. 13x is equal to 39, and then you can solve for x. And again, you can double check these things on your calculators now. X is equal to 3. Okay. So our answer is going to be 3 comma some y value. So what we do is we take x equals 3 and we plug it into one of these originals. Or you could plug it into this new equation. Usually one of the originals means less work. So I'm going to just pick this first equation, the 2x minus y equals 4. And instead of 2x, it's going to be 2 times 3 because x equals 3. So then 6 minus y is equal to 4. And, really I can just guess. 6 minus 2 equals 4. But if you guys really need to see it, the easiest thing I can think of is to add the y to the right, subtract the 4 from the left, and you got 2 is equal to y. That's a perfectly legit approach to solving the equation. So 2 is the y value. It's 3, 2. Yeah, let's try another one. Okay. We got 2 down here. All right, so we've got 2x plus 7y equals 1, and 4x plus 20y equals 8. So pause the video for a second and ask yourself, what would I do to try to get either the x's the same or the y's the same? All right, let's see. Did you guys pick multiplying the top by negative 2? Because in my mind, that's the most convenient approach. Positive 4x here, you want negative 4x up there. Plus, I don't have to multiply the bottom times anything. So, just to keep things consistent, the top will be black, the unchanged will be blue, 4x plus 20y equals 8 is the unchanged bottom. The top is going to be negative 4x minus 14y equals negative 2. Once you get it so that the twins are negative and positive here, add the columns, because that's the only way you're going to get rid of a positive number and its inverse. They're gone. This is going to be 6y. This is going to be 6. Again, you're getting nice, neat numbers here. That's just to kind of like give you some encouragement and confidence that, hey, I'm doing it right. I'm getting whole number answers. So you solve for one of the variables. Actually, maybe we need some space over here for number 3. Let's go to the opposite side. If y equals 1, let's then plug into, I think this top original one's going to be our more convenient one to work with. So 2x plus 7y equals 1. I got y, which means let's replace it with times 1. So 2x plus 7 equals 1. Subtract 7 from both sides. 2x equals negative 6. Divide by 2. Yeah, x equals negative 3. So x equals negative 3, y equals 1. Our final answer is going to be negative 3 comma 1. By the way, remember, you can check your answers by plugging the negative 3 in for x and the 1 in for y. And if they don't give you 2 true statements, you got to go back to the beginning and figure out what went wrong. Okay? Doing a quick mental check, though, I find that both of these do check out. Negative 6 plus 7 is 1, and negative 12 plus 20 is 8. So they both check out. Okay, number 3 is a little bit different. Clearly not in the way it looks because they're both ax plus by equals some constant c. They both have the same format. But it doesn't appear that I can just multiply one equation by some number to make it opposite the other. It's like I got to do something to both equations to make this happen. So what I'm going to do is, since I've got smaller numbers right here, I'm going to pick the y's to be the ones in which I'm trying to make twins. One's going to be a negative twin, the other's going to be a positive twin. Which means I'm going to have to multiply both of these equations by some number to make this number the same. So what's the smallest number that both 2 and 3 go into? 6, right? 2, 4, 6. So 2 times 3, 3, 6. 3 times 2. So here's what I'm going to do. I'm going to multiply the top by 2, the bottom by 3, and since they're the same sign in here, I'm going to multiply one of those equations by a negative to create the negative positive dynamic here. So, eeny, meeny, miny, multiply the top one by the negative. It really doesn't matter. So, let's do that. Negative 2 times 4x is going to give us negative 8x. Negative 2 times 2y is going to give us negative 4y. And then negative 2 times negative 14, positive 28. And then on the bottom, 15x, 9y, positive. Shoot. I totally messed that up. Let me strike that and reverse it here. Darn it. I'm not starting the video over again. I should multiply the top by 3, negative 3, and the bottom by positive 2. So my apologies, especially if you have this on mute and you're not listening to my explanation. Oh no. Sorry. Okay, so we got to erase those things. It's negative 3 times 4x, negative 12x, negative 3 times 2y, negative 6y, negative 3 times negative 14 is positive 42. Okay, I think we're back on track now. This is going to be 10x plus 6y. There we go. Now we got the plus minus situation going. And then 2 times negative 17 equals negative 34. All right. Now, because we've got this situation going, we can add the columns. Adding the columns gets rid of the y values. You're left with negative 2x is equal to positive 8. All right. The x value equals negative 4. At which point we take that negative 4, we choose one of our equations. It appears that the top one might be better. Negative numbers, it doesn't really matter. They're just a little bit smaller to work with. 4x plus 2y equals negative 14. Sincerely, though, my apologies. I did not mean to mess that up, but I did catch it when I realized, hey, I was trying to get 6 y's. Well, I don't have 6 y's. Anyway, the x value is 4 times negative 4, which gives us negative 16 plus 2y equals negative 14. Add the 16 to both sides and divide by 2. By the way, 2 divided by 2 is 1, not 0. I think some of you guys were putting a lot of, 2 divided by 2 is equals 0 on some homework, so make that adjustment. Okay, so it's -4, 1. All right, so I think you guys have elimination down. I just have one more example to kind of get some practice with word problems in which you have to actually create the equations. So let's dig into that before you guys check out. All right, so here's the situation. The owners of the Riverview restaurant have hired enough servers to handle 17 tables of customers, and we have a max of 56 customers that can be approved to be in the restaurant at any given time. How many 2-seat tables and how many 4-seat tables would accommodate these kind of 56 customer max and 17 table max? And it says write and use a linear system to find the solution. So here's what I see. 17 tables, 56 customers, and then we have 2 variables here. We have X number of 2-seat tables, and we have Y number of 4-seat tables. If we're just going to plainly apply a variable to each one in which they look very similar to what we've been talking about in our previous examples, seems to me like this would be a very good start. So let X equal the number of 2-seat tables, and let Y be the number of 4-seat tables. Now, the first thing I see right away is that there's 17 tables. They're basically saying we're going to have 17 tables in this restaurant. Now, the tables are either X tables, 2-seaters, or Y tables, 4-seaters. So we got our first equation here. The number of 2-seat tables plus the number of 4-seat tables must yield the whole number of tables. X plus Y equals 17. Furthermore, the number of customers that are sitting at those tables will be 2 customers for every X table, right? There's 2 customers at a 2-seat table. And there's 4 customers at a 4-seat table. So 2x plus 4y, that's how you're going to come up with the 56 customers. So it's kind of like we had a table equation and a customer equation. If you want to document that in your notes as like, okay, that's how he came up with these equations. These are all about the tables. These are all about the customers. Now, once you see that, you should be thinking to yourself, oh, this is elimination written all over it. The x's and the y's are already stacked. The constants are stacked on the other side of the equation. So I can just multiply this one either by -4 to get the y's to be the same or -2 to get the x's to be the same. I'm going to go with -2 and just rewrite this as a blue equation underneath it. So -2x minus 2y equals -34. Okay. Then I add the two. I add the stacks, add the x's, add the y's, add the constants. The x's drop out. The y's reduce down to 2, and then you got 22 on the right-hand side. 11 y's. So 11 4-seat tables. Yeah. And since this, you could probably do some mental math on this, right? If there's 11 4-seat tables and it has to add up to 17, then there's going to be 6. 6 plus 11 would equal 17 total tables. So the x is equal to 6. But, if you need to, do the normal route of take the 11 and plug it into the easiest equation you can use, which is the x plus y equals 17. So your final answer here would be 6 2-seat tables. I guess for the owner of the restaurant, it makes most sense to do 6 2-seat tables and 11 4-seat tables. So that all 56 customers could occupy that space at once after COVID. And yeah, you've got enough servers to handle them. Okay, guys, hopefully this was helpful and not super confusing. My apologies again on the third example. We all make mistakes. Just make sure you adjust once you realize a mistake has been made. Yeah? Okay. Thanks for watching.